Hey guys, today we're going to take a look at function notation and evaluating functions. So let's get started. So first, we are used to seeing equations that look like this. Y equals 3x plus 9. Well, when we talk about function notation, that y becomes this, f of x. A function of x equals 3x plus 9. So let's talk about what that means. First of all, this is how you read it, f of x. The next thing you need to understand is that your x is your input value. That is what you put into the equation to get your output. And the output is the answer that you get. So let's write that. The output is the value, let's use the word value. It is the value you get from the input or from substituting that in. So let's practice evaluating functions in function notation. So let's start with that one that we just had. We said that f of x equals 3x plus 9. And I want us to find f of 5. So the function of 5 is what I'm looking for, f of 5. So f of 5, that means I substitute 5 in place of every x that I see in that equation. So this becomes 3 times 5 plus 9. So once I substitute in the value, I just follow the order of operations. So f of 5 equals, remember first we do multiplication, so 3 times 5 is 15. And then 15 plus 9 gives us 24. So I input the 5 and I got out 24. So f of 5 equals 24. Let's practice a couple more. And watch this. Here I have g of x. The f, the g, whatever letter, that's just the name of the function. Okay, so I'm going to tell you that g of x equals x to the second power minus 12. And I want us to find g of negative 3. That means my input is negative 3. So g of negative 3 says I replace every x with a negative 3. So this becomes negative 3 squared. Notice I put a parentheses there because it's negative 3 times negative 3, and then minus 12. So now let's follow our order of operations. Remember, please excuse my dear Aunt Sally. So g of negative 3 equals, I do that exponent first. Negative 3 times negative 3 is positive 9. And then 9 minus 12 is going to give us negative 3. So g of negative 3 equals negative 3. Input of negative 3, output of negative 3. Let's try one more when we're evaluating functions. So let's name this function h. So h of x is 1/2 times x minus 6. And I'm going to tell you that h of 3, I want us to find h of 3. Our input is 3. So h of 3 equals 1/2 times, let's substitute in 3 in place of x. So I have h of 3 equals, well, let's do our parentheses first. 3 minus 6 is negative 3. And then what is half of negative 3? You have two options here. You can simply write it as negative 3 over 2. That is correct. Or you could say h of 3, remember fractions and decimals are the same thing, they just look different. Or h of 3 equals negative 1.5. So either one of those would be correct. So what if they tell you, so in the last few we evaluated the function. What if they tell you what the function is, but they want you to find x? So that's the next thing we're going to take a look at. Sometimes we go the other way. So let's say that I tell you f of x equals 78. And I also give you the function f of x is 6 times x plus 9. And I want you to find the value of x. So what you're going to do is you're going to substitute the 78 in place of the f of x, and then you're going to use what you know about solving equations. Now, typically I had you flip this, but I like the challenge of working these backwards, so I'm just going to leave it in this section. So first I notice I have the distributive property, so 78 equals 6x plus 54. Next I need to isolate my x, so I'm going to subtract 54 from both sides. So I get 24 equals 6 times x, and then I still need to divide both sides by 6 to isolate the x. So x equals 4. So when f of x is 78, x is 4. I could even rewrite it like this. F of 4 equals 78. Okay? So let's keep practicing. Let's look at another one. So let's say I have p of x, and I tell you that it's equal to 10. And I'll also give you the function as p of x equals 5/4 times 4 minus x. Well, once again, for p of x, I'm going to say that's 10. So 10 equals 5/4 times 4 minus x. And then I'm going to, because I want to know what the value of x, I'm just going to solve the equation. So if you'll recall, we have a strategy where we can get rid of that fraction. So I'm going to multiply by the denominator of 4. So that gives me 40 equals 5 times 4 minus x. Now I notice the distributive property. So I'm going to say 40 equals 20 minus 5x. Now I want to isolate that variable. Give me just a second. Let me add another page and move this picture. We're going to use that a little bit later. Okay, get back. All right, so now I want to subtract 20 from both sides. So I'm left with 20 equals negative 5 times x. I still need to isolate the x by dividing by negative 5. So x equals negative 4. So given p of x equals 10, x equals negative 4. And remember, we can also rewrite it like this. P of negative 4 equals 10. So now that you've seen how to go both ways, given the function and what to substitute in for x, and then the last two examples, we learned we were given what the output was, and we went back and solved for x. Now let's take a look at a graph, because we know that graphs can be functions as well. Well, we can also use a graph to find the values of f of x or g of x or whatever the name is. So I want us to find what f of 0 equals. But I want you to remember, we said that this right here is the same as y. So it's important that you understand that. And the 0 here is the same as x. So here's what we're going to do. I'm going to find when x is 0, and I'm going to go up to the graph, and I'm going to read what my y is. So if I look at this, I notice that my y is 1. So f of 0 is 1. Let's do the same thing for a couple more. Let's find f of 2. So I'm going to find where x equals 2, because my input is x. I'm going to go up to my graph, and I'm going to go over and see what my y value is, and it's about 2. So in this case, we're going to use 2. So f of 2 equals 2. Let's do one more. And you can do this with any parts of your graph. So now let's find f of 5. So remember, our input is our x value. So when our x is 5, you go to your graph, and then your output is your y. So here my y value is 9. So f of 5 equals 9.